Yeah, Hardik. Thank you. Thank you.
Sorry. So, so guys, this is second class of our PCB designing course, and here in this course we will learn how we can make PCBs in KiCad. So let's start. So in our previous class, I have shared this link with you. With the help of this link, you can download KiCad. I hope most of you have downloaded it yet. If not, I will share the link again. So you can just download it from that link, and it is cross compatible. So either you are using Linux, Windows, or Mac, so you are able to download it. So in this course we are using KiCad. So I request you, all of you, to just download it and start making stuff. And PCB designing is something when you don't do, and if you only watch the lecture, then you won't learn much of it. So you have to practically do stuff and make new stuff and experimenting with new ideas, and whatever your creative endeavor. Okay, so this is our today's objective. So today we will try to understand what is schematic and how we can make schematic in KiCad, and identify the use of electronics components correctly, and what is footprint and how we can assign them. And another objective is to understand the PCB design rules, and what are the rules and why we need rules. And in last we will make a simple schematic of LED and button circuit. Actually, this is assignment for you. So whatever we learn, we will use in this project, and you have to make a simple schematic with LED and button circuit. Okay, so let's start this lecture. Yeah. So the first question arises: what is schematic? So as I already told you in previous class, so schematic is simply component connections. Like we tell our software how to connect components. Let me show you on KiCad. So on KiCad, let me open cursor. Okay, I hope my cursor is visible now, right?
Yeah, Hardik, it's not visual. Mm,
Wait, let me share a complete screen. I guess it is partially shared.
yeah, maybe.
Entire screen share. I hope now it is visible in blue color.
Yes, yes, now it's visible.
So this is our main KiCad window, and this is here I have opened the previous project flashlight. This project we make in previous session. So while we make any project in KiCad, so we have these two files. The first one is PCB file in the green one, and this transparent gray sheet is our schematic sheet. So here we are talking about schematic. So this is the schematic file. So we can just open it. So this is our schematic file, and this is the simple schematic we have we have designed in previous class. So here is our battery, and here is our resistor, and here is our LED, and we have connected them. Simple LED circuit. So as I already told you, what is schematic? Schematic is basically component connection. So this we call it schematic, and each component has a symbol and a footprint. So here we have three components. You can see the first one is battery, resistor, and LED. So each schematic consists of two things. The first one is symbol, this symbol, this resistor symbol, and another thing is the footprint associated with it. To check the footprint, you can just double tap on this, and we will see this symbol properties. So in symbol properties, we have this option footprint. So footprint is basically the physical shape. So the thing is, in electronics, there are many shapes available, many different sizes available for the same component. You can get 1K registers in different varieties of packages. Like just like cars, in car we have different type of options. Like you can buy hatchback, you can buy some off-road vehicle like Thar or some G-Wagon type stuff, or you can buy some sports stuff like Ferrari. So similarly, we have different options in the registers itself. So for example, let me show you. uh, we have different type. Let me open my browser. Okay, let's open and let's see different types of components. uh, Component footprints, images. Yeah, so these are the different type of packages we have. Like some ICs, we can have QF. These are the numbers. These are the packages names. You don't have to fear that much. So I'm just explaining the types of components and different varieties and different shapes they are in. So here we have this QFP32 package, and this is flat dip packages. So let me show you register component footprint. Yeah. So this is the like I have told you. So this is the same 1K registers, the same 1 kilo ohm registers are available in these many types of varieties. So here is the type number. 0201 is the code, and like 0201 is the smallest one. So this is a 0201, and incrementally we can go on. So these are the different types of packages we can. If we want to use 1K registers, we have to tell our software that we want to use which package. So we will assign this in footprint part. Any doubts so far? Hello, am I audible?
Yes, yes. Guys, like anyone having any point, any doubt, just tell. Okay. Yeah.
So guys, do you have any doubt? Just ask it immediately, and just get it clear. Okay.
No, no.
Yeah. Okay, I will continue. So each component has two parts, simple and footprint. So the third part is wires and nets. And so let me open that schematic again. So uh, so we have covered the footprint. Now you can see these green wires. So what are these? So these are, we call it nets in PCB designing language. So these are nets. So with the help of nets, we can connect stuff. How we want to connect, we want to make series connection, we want to make parallel connection. So with the help of nets, you can, these are similar to wires. So you can connect two components with the help of wires. Yeah, so this is the schematic part. So now the question arises how to draw a schematic. So in KiCad, we have two options to make these type of schematic. The first one is you can go on this icon, this place symbol icon, this pop amp icon. I hope you can. I hope it is visible. Yeah. So you can click on this. So here we have. So here we have all the components, all the symbols in the KiCad library. So the first. So this is the first method, and another method is you can just press shortcut key A on the keyboard and it will appear. So here you can type the component which you want to use. Like if you want to use register, just press R. And here we have our register. And if you see carefully, here we have no default footprint. So you can assign footprint from here. Okay, so let's assign footprint later. So let's place a register here. So here we place a register. Let's suppose you want to add capacitor. So just we will press A and write C. Okay, so here we have unpolarized capacitor. Just click on it and we will get the capacitor. Okay, so similarly you can place LEDs by pressing D, or you can just type LED, or you can place switches or ICs. Okay, so for now I will delete this. So these are the symbols. And another thing is, if we want to place power ports, like let's understand what is power port. So power ports are something related to power, and we have, like, if you want to add VCC or 5 volt or ground, so we can click on this ground icon. So this is the first method. Another method is to just press P on the keyboard, P shortcut key on keyboard. And if you press P, then these are the power ports. So here you can see we have different options, like 1 volt option if you want to connect our power supply to 1 volt. So here you can get that. Okay, so let's take for example, let's take 3.3 volt. Okay, so just double tap on it, and here we have. So this is our positive rails. Let's add ground. Again, press P, then search G and D, and we have this ground option. Let's just place it. So this is how we can place the power ports. Okay, so this is the now footprint and libraries. Okay, so in the main KiCad window, so this is the schematic. We have opened this schematic. Let's close this. So we can edit these footprints and symbol. So here we have footprint editor. So you can just open it. So these are the all footprints available in the KiCad library. So you can just open it, and if you want to edit them, you can also edit them. If you want, like you want to make some custom part, so you can edit it here, or you want to import some new library, you can also download you can also download these new libraries from web. I will show you later. Let's open it. Okay, let's open Arc. Okay, so you can download your components from Snap EDA, Snap Magic. So here, let's suppose for example, I will take this LM358N example, and I will view this part. And here we have the symbols. So this we will place in schematic and the footprint, which helps us to make PCB and the physical structure of that component. So you can download this with the help of this button, download button and symbol. So I will share the link of this website in case you want to explore this. Okay, so let's just download it, and I will download it for. So here we have multiple option. You have to select KiCad and select this option V6 and later. So our library is successfully downloaded. So let me just open it. So this is our library. We have to unzip it. Yeah, so here we have the zip file. So now we have to add this library in our main KiCad window. Let me demonstrate how we can do that. Okay, so this is our main KiCad window. So first we go on preference, and here we have an option manage footprint library. So let's just click on it. So here you can see we have all files, all the symbols which we earlier see in the library. So let's just click on this plus button, and we have to click on this folder icon. And you can see we have to, all files here are .keycat symbol, has ending with KiCad sim file. So let's just add KiCad sim file here. Okay, let me. Okay, so here I have, I think I did something wrong. So let's click on this, and this is our library of SS12D00Z3. Let's click on it and add anyway. Okay, so why let's name it test. Okay, so let's click on OK. Now it is giving error because of this. We have this empty cell. So let's just clear it. Okay, and now we will add. It will add. So similarly, we will add footprint. So for footprint, we have to click on this icon, and here we have to enter the path of that particular footprint. Like this is the path, and click on OK, and let's name it test. So now this that component is visible, and we can open that component in our schematic. So let's click on A. So let's type test. Guess it is not updated. I guess let me check it again. Preference, configure part, manage symbol. Okay, in symbol, okay, we have accidentally entered the wrong file. So let's edit again, and let's go on downloads, and here is our file. Let's open, and this is our LM35. Okay, so let's delete it, and let's copy this name and click on OK. And similarly add the footprint. So here is our component. So this is how we can import new libraries in KiCad. So this is the same component we just downloaded from Easy EDA. Sorry, from Snap EDA. I hope that is clear to all of you. Is there any doubt? Hello. Okay, so next is design rule check. So let's understand what is design rule check and why we need it. So design rule check is basically like in simple term, we just compile our program to check if we did some obvious mistake like indentation error or some assigning to a variable which we haven't uh, assigning to some variable which is not global. So these type of similar mistakes we can also do in PCB also. Let's suppose we forget to add something, we forget to join two components. So with the help of design rule check, we can identify those, and it will help us to identify. It will help us to basically understand what's the obvious mistake is. So uh, so let's understand why we need design rule check. So design rule check helps us to prevent short circuit and ensure the manufacturability of that particular PCB. So let's understand what is manufacturing, what's the manufacturing constraints and why it is important. So generally when we order a PCB, so let's suppose, let's open. So guys, do you know about any popular PCB manufacturer that manufactures PCB? Generally, if you any how-to videos on YouTube or somewhere, so you have heard of JLC PCB. Have you guys heard of it?
Yes, sir.
Yeah. So let's open that website and see see those manufacturing constraints. JLC PCB constraints. So you can read all these information by just typing the manufacturing company name and constraints. So here we have. So these are the PCB manufacturing assembly and capabilities. Okay, so every manufacturer have different capabilities, and so they use different machines. So these are just these. This is their constraints. So, for example, if we buy some new scale, so what we generally identify is what is the least count, and what is the error percentage, and all those components. So similarly, we did here. So this is the minimum and maximum. Uh, this is the minimum and maximum they can go. So you can read all this from here. Like they can make a PCB up to 1 to 32 layers, and impedance tolerance is 10%, and all those. Thickness is 0.4 to 4.5 mm. Traces. So this is the minimum track width. So if we design a PCB and this is the minimum width, they can manufacture. So these capability, all these capabilities we can read it from here and put it in KiCad. So if we void any of these constraints, so KiCad will give errors and helps us to help us to remove them and helps us to remove them and okay, let me just show it to you. So you can set these constraints from by just opening the KiCad PCB editor. Here we have. So you can set these. Here we have board setup icon. You can just click on it, and here we have all the layers. You don't have to fear that much. We will explain later these. So here we have design rules, constraints. So here we have to type those constraints from that particular manufacturer. Let's suppose if we have a JLC website. Okay, so minimum track width. So minimum track width is 0.10. So we can place that 0.10. Yeah, here. So minimum track width 0.10. Okay. So this is the minimum track width. Like similarly, we can type our all constraints here, and we click on OK. And if 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 we pass that those constraints, so then when we design rule check, when we click on design rule check, it will give us error. Okay. So this will eventually helps us to identify the manufacturing mistakes earlier. Close. Okay. So similarly, this is the with the track, and there are also hole sizes and different constraints. Like this is the traces, and in drilling part, so we have this minimum hole constraint. Like we can't go less than 0.15 mm. So we can also set all these constraints in the board setup. Okay, so let's jump on that assignment. Let LED plus button circuit. So this is a circuit. Let's open a schematic. So this is the circuit we have made it earlier. So now we will add a push button to it, and so to add push button, let's remove this net and click on A, and we will type push button. Let's arrange them so we can connect them. So to connect them, you can just go on that particular wire, and you have this green line option on it, and click on it, and we will join this like this. And so what do you guys else want to add in this? Any suggestion, any recommendation? Okay. So let's save this, and so to import changes from schematic, you can go on tools, update PCB from schematic, and click on update PCB. So here we did a small mistake. So here it is showing error. Cannot add SW1. No footprint aligned. No footprint assigned. So basically, it is telling that you have added a component in schematic, but you haven't assigned a footprint to it. So we can't import it in PCB. So let's assign that footprint first. So let's go on schematic and click on that switch button. And here we have footprint option. This is properties panel. And here we have footprint option. Let's click on it. Let's type switch. So you can also see the 3D view of it. Just click on here. So here we have different type of push buttons. So let's use this one and click on OK. So now we have successfully assigned footprint to it. Let's just run DRC, run ERC. So we have 0 errors. So let's suppose if I short this battery just to experiment and to demonstrate the importance of ERC and how it will show the warning. So let's just what we can do here is okay, and so we have shorted this battery, and now if we run ERC, let's see what happens. Run ERC. Okay, so I guess there is some error in this. Ideally it should give us error, but it is not giving error. Okay, so now if we compile it and run ERC, so it will give us error, wire not connected. So symbol button pin, passive line, and horizontal error pin not connected. So ideally it should give error like that, but unfortunately when we short this battery, it is not giving error. I guess there is some bug in this. So let's just connect it. So here we can also learn that by just running ERC, we can't be 100% sure that our circuit is absolutely fine. So you also have to review it carefully before sending the files to manufacturer. Okay, so let's run ERC again. Now we are good to go. So let's just import changes in PCB. So let's open PCB. So here is our PCB. So to import changes, we have to click on Tools, Update PCB from Schematic. So let's click on Update PCB and close. So here is our push button we just assigned. Let's change this name. So this is our class 2. And this we are going to change this version number also, because in previous version there is no switch, but in this version we have a switch. So let's click on OK. So this is V2. Okay, so let's just drag and drop it here. So these have you seen this? So these are the guiding nets which tell us like where this pad needs to be connected. Okay, so let's just remove this line. So to remove, just select it and click delete shortcut key. Okay, and let's shift this overall circuit so that our button gets some space. Let's shift it little bit. Okay, what if we use some, let's change the footprint of this switch as it is very big. So let's change the footprint. So just double click on it and let's change the footprint. So this switch is very big. This is 12 mm. So let's use 6 mm switch. So this is our 6 mm switch, and here is the reference 3D diagram, and let's click on it. Okay. Click on save, Control S, and update PC. Let's update this PCB. Click on tools and update PCB from schematic. Update PCB, close. So here we have a smaller switch. So now we can fit this in this space. So generally this is what practical application of having different footprints. So generally we are dealing with complex spaces and complex shapes. So in order to fit components in that particular area, we choose smaller footprint components. So like similarly here, initially we are using 12 mm switch. So but we won't able to fit that here. So we reduce the size of that particular component, and now we can accommodate it here. So uh, let's just connect them. Okay. So let's rotate it. So to rotate it, you have to select this particular component and click on R. Okay. So this is our overall. So can we rotate it? Can we place it like here? Okay. Okay, let's connect them. So to connect them, you have to press X on keyboard and it is go in wiring mode. Okay, so we have to connect it here, sorry. Let's remove these lines. Okay, let's see how these nets are going where. Yeah. So this is the correct orientation. So let's just connect them. Press X shortcut key and again same. Okay, so let's shift this circuit a little bit. Okay, so we can see this in 3D. So to view it in 3D, click on view and we have this option view 3D. So this is the updated PCB we just make version 2 of our previous. Okay. So guys, any doubts so far? Hello. Vishnu, any doubt? Okay. So now you can make this or not. Anything you don't understand, or if you have to make the same replica of it, can you make it?
Yes, sir.
Okay. So let in the so you can practice this, and I suggest you to add 5 LEDs. So here we have add a single LED. So you can experiment with 5 LEDs, adding 5 LEDs and 5 LEDs, and experiment with few footprints and how we can use different type of switches there. And if you have any doubt, or uh, any query you don't understand in this class, you can directly ask in the group, or you can directly message me. So this is my number. You can directly message me, or you can ask in group. So any doubt so far? I hope you understand the assignment. You have to add 5 LEDs in the same project. So guys, is it clear?
Yeah, I think anyone having any point, any doubt till now, the PCB, this one is second in the second PCB design. Anyone, just speak out. Yeah.
Yeah, don't be shy about it.
Hello, sir.
Yeah.
Can we take one demo session on how to read a schematic?
Sorry?
Can we take one demo session on how to read a schematic?
How to?
Read schematic.
How to read schematic. Okay. So, can you do you have any example of some open source design, or some board you want to read schematic?
Any board.
Okay, any board. So let's sorry, we can't do a separate demo, but I will explain a simple schematic diagram in this class itself. So so let me show you. Okay, let me show you a design, and we will see how we can read that schematic. Yeah. So my screen is visible?
Yes, sir.
Yeah. So this is one of my previous project. I have made this. So generally we start with power. So here we have this USB-C connector, and we have some bunch of capacitors. So can you specify what generally you what difficulties you are facing while reading schematics? What you don't understand, what part you don't understand, what you want me to focus on? Hello.
Hello?
Yeah. Yeah, Komal.
Can you please repeat?
Yeah. So I'm asking is, can you can you help me understand what problem you are facing while reading schematic? What's the exact problem you are facing? Like what are so in which part you are getting confused?
Firstly, read schematic is creating PCB design.
Creating schematic or creating PCB design?
Creating PCB design.
Okay, creating PCB design. So how we go from schematic to PCB? You are asking that?
Yes.
Okay, now I understand. So okay, let's go on schematic again, and let me show you again. So this is our previous schematic, right?
Yes, sir.
Okay. So whenever you get confused, just try to understand the basic electronics concept, like current flow from positive to negative, right? We agree on that.
Yes, sir, I agree.
Yeah. So current starts from positive and goes from here, and here we have a switch here. So it is blocking the current, and here we have resistor and LED. So this is the complete open loop circuit until you press that push button. So when you press that push button, it starts flowing from positive to ground. Okay. So this is the simple uh, basics of a PCB. Current flows from positive to negative. Okay. So after making this, you can save this, and you can go on PCB design. Let's suppose for now we will delete this. For a while, we can undo it. So let's click on tools. To import changes from schematic, you have to click on tools, then click on update PCB from schematic. So when you did this, it is telling like these are the changes. Okay, so when we click on update PCB, it imports all the changes from the schematic. Okay, so let's just close it, and here we have our all components, and you can see here this small blue color net. Okay, is it visible?
Yes, sir.
Yeah. So this is telling us that this pad is connecting to this pad. So we have to connect them.
Okay.
Yeah. So this is how you can import changes from schematic. So I hope your question is clear, right?
Okay.
Let's just undo it, undo these changes. Yeah. So here is our PCB back. So any other doubt?
No, sir.
Okay then, I think fine. And today, this was the last one, and by the next Sunday with the same time, yeah, we can change some time like 5 to 6. We'll go with regular class. Okay. In the meantime, how to register the course, how to get the access, just ping it to me, and today video you will get, and today PPT means I will request to Hardik to share in group as well. Okay, and those who wants to join, just let me know in call only. Okay, here only. And yeah, in the meantime, I am sharing the Hardik shared some of the links I will share in the group. I think like all of guys wants to join the course, right? Yeah, I'm sharing the links to here. Just let me know who going to join, yeah, who like the course and who like become the part of this course. Just tell me. How to join is very simple. Go to the PCB course, as I said already. Okay, and I am sharing one more time. Yeah. So go to this link. After going the link, here you will be get the I think purchase option. Let me show to you how you will get. Suppose I am logging with this user. Okay, so go to the course. After the course, here you will come, then you will comes to here, and also I think there are some coupons. If you apply, then it will be fine. Go to check the coupons. If some coupons are I think available, yeah, not. If not, I think yeah, go to that last at the here offer and try to use those coupons if like anyone working, yeah, not. I think some of the coupons are working. It is very helpful to you if you want to register. Okay, yeah, as you can see, some of the coupons are working right now. Skills India, go and try, and I think complete your transactions. I will add you on the separate group, and you will be get the notified about the next next regular class. I think I think all of you know. So whatever the content of the course, I already shared with you, and like still you guys are confused. Like if it is relevant for you, then you can join. If not, then we can see. Okay.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.